So welcome to my talk. The goal of this talk today is just to give you the big picture of what you're going to be able to automate when you work on iOS projects, but also to share some of the automation and the code and the resources with your Android team. So I won't go deep into details about all those tools. I encourage you to look for the documentation and stuff like that on the blogs about all the tools I'm going to talk about. The main idea here is mainly to present what exists and what you can automate during the process of an iOS and Android application. Maybe we can have the slides. Yep, better. So, of course, the first thing you start when you create a project is just find a project, and we're going to even start automating that tool, that step. You may wonder why automate the creation of a new project, because it's just a matter of finding a project and that's all. But actually, that's way more work, because after you've find your project, you will have to configure your Xcode project with build phases or build settings. You will want to organize your folders the way you prefer, because maybe you use MVVM or Viper or whatever architecture you like, and you will want to organize the folders and the files of your project accordingly. So it takes a lot of time to do that manually. Same for the build phases that you want to configure, or even the SDK that you usually use in your project. Maybe you are using SDKs like Firebase or Crashlytics, and you don't want to configure that for all of your projects every time. So instead of having a checklist and following the steps manually, we can automate even that first step of a project. So what we use at my company is a tool called Liftoff, and it works by providing a YAML file when you define how you want your project to look and what you want to configure in that project in terms of build phase and organization and structure. And once you have your template ready, every time you want to create a new project, you just run Liftoff. Then it asks you a few questions, like the project name, the bundle ID, and some other questions. And it will generate everything for you, and you will end up with something like this, so a basic Xcode project, but with everything configured, like all the folders organized appropriately, and the targets with the right names and the right bundle IDs, and even the build phases, custom build phases that you might want to add. And it even generated a proper app delegate with not the default one, but the one with all your content that you asked Liftoff to create. Maybe some lines to configure Crashlytics or other frameworks, other SDKs. Maybe some keys in your info.plist. Everything is done by the tool. It can also create other files next to your project, like a README, a pod file, and whatever configuration file you might need for your project. So once you have that, you will want to start adding, when you want that, you can use Liftoff like we did, but Liftoff is actually not really maintained anymore. So we use that because we started automating that a few years ago. But now Genesis is a more recent tool that does exactly the same. It works with a YAML file, same as Liftoff, and asks you a couple of questions and does the generation for you. But it's more recent and more maintained. So if you want to start with automating your creation process, Genesis is the right tool for that. Once you have your skeleton of a project, you'll add your libraries. I'm hoping that most of you already know about CocoaPods or Carthage. If you don't, please look it up, and don't add your libraries by adding the files manually in your project, because those dependency managers allow you to list all the libraries that you want, even with some versions. that you want, and it will solve every dependency, so every libraries that those libraries need, the transitive dependencies, and download that for you and configure everything for you. And if you want to update one library later, you can just run pod update, the name of the library, or Carthage update, then the name of the library. And it will fetch the new version and all the versions that are needed for those libraries as well. So for maintenance, it's very important, and it's also easier to do and to update your libraries instead of doing that manually. So in the future, we'll have a Swift Package Manager. For now, it doesn't work well with iOS projects. So CocoaPods and Carthage are still the way to go. But anyway, using a dependency manager like that is very important for your libraries. But then something that many people don't think about automating is actually creating your data model. So maybe in your project, you'll likely manipulate object models, and maybe you want a database for that. So many of you who have done mainly iOS development might know about core data. And core data is really good and fine, really powerful. It's well integrated with your IDE, with Xcode. But the only problem is that it's not compatible with Android. And at my company, we do iOS and Android projects, and we want to share as most as possible when we use tools that works on a common code base. So we looked at Realm, which is an alternative, a third-party library that does database and persistence of model objects. And Realm is really, well, it's well known in the database community. Now it's really common to have projects with Realm. And the good thing with Realm is it's cross-platform. So you have Realm Java and Realm, which is actually accessible with Kotlin if you need, and Realm Swift with the same API. So your Android team and your iOS team can talk to each other. Like, how do you do that? Do you know if there is an API to do that kind of query and stuff like that? And they can discuss with each other because they use the same API and the same framework. But we wanted to go further and to make them use the same data model as well, because they want to discuss about the actual models and the actual properties of those models when they meet to discuss user features. The only problem with Realm compared to core data is that there is no visual editor. So if you want to create your database and define what you have in your database, the entities and attributes, you will have to write code manually in Realm to declare all those. And I missed a lot the visual editor in core data that we have in core data. That's why we wanted to have it back. And that's why we created a tool called Gyro. So if you've been at DevFest last year, maybe you've heard of it. There was a talk about it. Basically, the idea of Gyro is to take an XC data model as an input. You will be able to define your data model visually, but we won't use the XC data model file to do core data. Instead, we'll feed that to Gyro, which will generate all the code in Swift and in Java or Kotlin, whatever you like, for your database objects. So it's easier to maintain because you don't even have to write those files. They got generated by Gyro. But if you edit your XC data model later, maybe your team, Android and iOS teams, are going to meet and agree on which field they want to add, how they want to rearrange the database. They run Gyro again, and then we have their code, the Realm code updated. So that's really important for us to share those features between the teams, because it allows to have more discussions between teams instead of having separate teams working in each side of their room. And communication is key when you want to implement the same feature in Android and iOS. So it's important to share as much as possible in there. Once you have that structure of your project, so we created a skeleton, then we add libraries and other objects, you have a good foundation, and then you will start to add code to your project and resources. But even with resources, we can automate some stuff, especially what I don't like with UIKit is that there is a lot of APIs in UIKit that requires strings to access resources. So every time we want to access an image, you will have to provide the name of the image, your image named. And in that name, you can easily make a typo, like I actually did there. And it's easy to miss. Maybe some of you didn't even see the typo there. But the compiler won't even tell you about that. Will silently compile happily, and will end up just having an empty image at runtime. Same for storyboards. If you mistype the name of a storyboard or a storyboard scene identifier, your code will likely crash at runtime. And same for localization strings, fonts, and a lot of other resources. Mainly every resource in iOS is accessed with their string. So that means no autocompletion, it's error-prone in terms of typos, and the compiler won't tell you anything. In contrast, in Android, they have the r.java file that got generated every time they compile, that got constants for every resources they have. So they have safety and compilation checks when they compile. So that's what we wanted to bring to our iOS projects. So there are multiple solutions for that. One is r.Swift, which is the equivalent of r.java in Swift. And the other one is SwiftGen. So SwiftGen is the one we use at my company, both because it's more customizable and because I'm the author, so better use my own tools. The concept with SwiftGen is that it scans all your resources in your project. So resources like images and colors in your XC asset, your asset catalog, and also custom fonts that you might have, your TTF files that you might have in your project, any storyboards, if you're an IB person, IB user, storyboards, scenes, and segues, and Xib even. It can scan all of that, find all the identifiers, and the strings as well, the keys for the localization strings. And from all of that, it generates the constants to access those resources. So the constant is not just a constant with the string as a content. It's directly a constant that will return a UI image or color or font. And that means that once you have the constant in your IDE, you can just type, for example, font family, dot, and the autocompletion will list all the custom fonts that you have in your project. And then you choose the font avenir and dot again, and you'll have all the variants of the fonts. Same for images. Well, this example is kind of flat, but if you have in your asset catalog multiple images organized in folders, it will reproduce that structure. So we'll have asset.fruits.banana, for example, if the banana image is inside a fruits folder. And it returns actually fonts or image assets directly instead of just strings. So you don't even have to then call UA image named something. And for strings, it's even more powerful, I think, because it scans your keys in your localizable strings, sorry, and generates one constant for each. But it also looks at the translation for that string, and if the translation contains placeholders like %at, %d, %f, it detects those, and it generates a function instead, which takes the appropriate parameters. That way, when you call l10n.home.welcome message, you will be sure to be requested to provide the proper parameters, so string first and int next. You would not risk to invert those if you were to call string with format yourself. So the implementation that is generated by SwiftGen for that function basically do all the NS localized string to fetch the key, and then string with format, but now it's type safe, and you are sure that you provide the proper parameters for that. So that's for accessing resources. I didn't show you all types of resources because SwiftGen can do a lot more, but a lot more kind of resources. One of the things that we do with that as well is that with latest iOS, you can put colors in your assets catalogs. So it can generate colors, constant for your colors there. But you can also use instead SwiftGen to pass colors.xml files that comes from your Android project. So if your Android team has a colors.xml file and you want to share that with iOS, you can just grab their colors.xml file and SwiftGen will generate all the constants for the colors. So it also helps you synchronize with your team here again. Talking about generating code, another thing that you can automate is actually writing code for you using Sourcery. So I said with resources, Android project have other Java. We don't have that, so we created SwiftGen. But Java also have annotations. So I don't know if you have seen any annotation in Java, if you're all iOS developers, but basically you can annotate with a special syntax above some classes or above some types or some properties to give some meta information about those properties. So maybe it's is to tell you to generate some code for the JSON parsing of those properties or stuff like that. We don't have that in Swift, but Sourcery provides a way to bring that to the iOS world. So that's not the only thing that Sourcery can do, but that's, I think, the most significant thing that can be compared with Android. So basically, what Sourcery does is it scans your code, the code that you wrote in your project, and it builds metadata about the code, so it knows about the lists of the classes, the structs and the enums, all the types that you have in your project, and all the protocols that those types conforms to, the list of the properties it has, the types of the properties, and you can use that metadata to generate more code. So it's really meta, it's kind of an inception tool, but basically what you can do then is that you can use that data to write a template to tell it to generate more code. So something like that, maybe. That's an example of a template to generate the equitable implementation of your type. So if you've already switched to Swift 4, maybe you know that if you conform a Swift type to equitable, now the compiler auto-generates the implementation. But if you want a custom implementation for your equitable, maybe you want to omit a field, a property, like I wanted with comment in the model before. Then you still have to write the implementation of equal yourself, and that can prove cumbersome and a lot of work to do. And more importantly, it's risky because you will risk to forget to maintain that custom implementation. If later you add a new property, you will likely forget to add it to the equal implementation. So if you use Sourcery to generate that implementation instead, you can tell every time you compile that Sourcery can regenerate those implementation if needed and update those, so you'll be sure to not miss this kind of code to update. And the template that you can see here, I don't know if you're familiar with templates and template engine, but basically it's a little like PHP and HTML when you have instructions to tell you what to do mixed with literal code. So the instructions that you have here in blue are instructions for your template engine, and everything in red is just literal code. So here we ask for Sourcery to iterate over all the types that are in your code base, and for every type that implements that auto-equatable protocol that we did, it will generate extension, so just the literal string. Then it will insert the name of the type, then equatable, start with static func equal, and then for the implementation of equal, it will again iterate over every property, so every stored variable in your type, and you can just compare property for every iteration of the loop. You compare the given property, except for the if the property has the annotation skip equality. So this test here shows that Sourcery was able to capture the special comment that we added just before the comment. So it was able to catch the Sourcery skip equality special comment, interpret that, and now you can use that in your template to tell it to skip that specific property. So that's why I told that it's kind of similar with to Java annotations. But you can actually do way more in terms of code generation with Sourcery. There are plenty of other applications. So I wouldn't want to show you every possible application there, but I encourage you to go to the Sourcery website or to blog posts that talks about Sourcery. There are plenty of examples of what you can do with it, and some are pretty powerful. The next thing we can automate as well is localization. So we saw with SwiftGen that we were able to scan our localizable.strings files to generate constants for them. But what about generating those localizable.strings files themselves? Because if you write your localization.string files yourself, you're prone to errors when you have multiple languages. You have to ensure that all the keys that you use in all the languages are the same, that you don't forget to add a key in all the languages. And once again, we want to share the translations with Android, because we don't want to translate the app twice. So it's also important to have a common source of truth between Android and iOS in terms of translations, and then to have all those strings files both for Android and iOS generated. And the drawback that we have if we generate the strings manually as well is that you have to know about the format. And maybe your product owner, or your product manager want to edit a translation, or maybe you have a dedicated translator that you pay to do all those translations, and it has to have a way to edit those files, to edit those translations without any knowledge of the formats. So there is some format that exists, like xlif, to allow to send translation to translators. But it felt to us way easier to use a service, an online service, to allow everybody that has access to the project to edit the translations in a nice UI. So there are multiple services that exist for that. As I said at the beginning of the presentation, my goal is just to give you an overview of what's available, but I'm sure that I forgot a lot of services. But I think the two that are most known are PO Editor and PhraseUp. So I'll let you compare the pricing plans and whatever to choose the one you want and the one that fits your needs. But basically, they work the same as they provide a a nice UI in a web page where you list all the keys for your project, all the languages, and then you can translate those either manually. You can pay them to translate those, but you can also translate the keys manually. But you have a nice UI to fill all those translations. Your project owner can also access that and edit the translations if they want to. And once you have that, you can just click a button to download the localizable.strings files or the strings.xml files and move those into the lproj folders or the resources in Android. But it's still a lot of clicks to do, to have to do that in the UI. And if if we keep that, it's still better than writing the files yourself, but if you have to do multiple clicks and move the files manually, it's still error-prone, and you will not update your localizable strings files as often as you should. So, of course, we automated that as well. So if you use PhraseApp, they come with a command line interface built in, when you can do a PhraseApp pull, and you have all your strings installed in the proper places. You just configure that in a YAML file, and you've done. And if you use PO editor, you can use Poesy to do the same. So that's another tool that we developed at my company, and that is open source. So you can use Poesy to automatically pull all the translation from PO editor and install them at the proper places. And you can do that, of course, for iOS and Android as well. So it's just a simple tool that uses the REST API of Poesy, of PO editor. But it's really handy because now you can just open the terminal, run the update strings shell script that you created, and it will download everything for you. Once we have all that code created, that's already a great achievement because we didn't have to write to configure the project. We didn't have to write a lot of code about equitable, or we didn't have to write the constants for the resources. But we still have to write code manually, sadly. Well, otherwise we wouldn't have a job anymore, so it's still good. But when you write code, maybe you didn't have your morning coffee, so you always do some mistakes along the way. So it's important to check for the quality of your code with various tools as well. So one of the tools that you might already know is SwiftLint. So if you don't know about SwiftLint, it's a command line tool that analyzes your code and, well, lints the code. So what we mean by lint is that it analyzes the structure of the code and the syntax, and it can warn you about either the code style, so you can tell SwiftLint that you prefer maybe curly braces to open your function body at the end of a line, or maybe at the next line, and you configure that, and it can tell you if you don't respect the rules. So it can be used to enforce a code style, coding style in your code base, but more importantly, it can also be used to detect common errors, like maybe you created a delegate property, but you forgot to mark it weak. And if you didn't mark it weak, maybe you will have a reference cycle and memory leaking in your code. So SwiftLint will warn you that maybe you want to add the weak in there. And you can also detect stuff like when you force unwrap an optional, maybe in your code style that's a red flag, and you want to make SwiftLint generate a warning, or even maybe an error to prevent any developer on your team to ever force unwrap. So that's some examples of rules that SwiftLint can check for. There are plenty of rules that I don't know how many, because many rules have been added recently. I think it's over 120 something, and very various and very configurable according to what you want for it to check. But it also allows you to have a consistent code base across your projects and across your developers. Another important task when you develop in a team is to do code reviews. So if you don't do code reviews, I encourage you to do it even for small teams. Even if your team is only 2 persons, 2 developers, it's important to do code reviews for multiple reasons, actually. The obvious one is that maybe the one that wrote the feature might have made some mistakes because he was or she was too focused on the code. And we are only human, so mistakes can happen, and a new set of eyes is always interesting. But it also allows you to learn about what the code was written, what code was written by your collaborators. So maybe someone in your team worked on a feature and had to implement a helper function, a utility function for their features. And when you do code review, you learn about that, and you realize that you can use that helper for your own feature. So it's not just about telling the mistakes, but it also allows you to learn about the existing code, and maybe also to learn about the patterns, because maybe another developer used an interesting pattern that you don't know about, and you will learn about that while you're reviewing the code. So it's not about only about complaining, but it's still a dangerous path to when you do code review that you might end up doing, because for example, I have OCD. I'm very I want things to be very strict and perfect. So every time there is a space missing or something, I just want to tell to fix that. But then I'm the annoying person on the reviews that does all the pesky comments. And even the comments about common stuff, not just syntax or whatever, but maybe you want to enforce that every person that does a pull request on your code credits themselves in the changelog to tell what they did and who did that, because it's important to credit work as well. And I used to do those comments manually, especially on my open source projects, to tell every new member, oh, welcome, thanks for the pull request, because I saw that it was a new contributor, or please add a changelog entry to credit yourself. And it's kind of repetitive and very boring task to do for code review, because we want to focus on the features and on the functional stuff of the review. So that's why you want to automate all the pesky remarks or style remarks using a bot. So the typical solution for that is to use Danger. So Danger is a tool that will analyze your pull request and get metadata about the pull request, like the title of the pull request, the description, the author, the date, and even the branches, the base branch and target branch, the list of files that this pull request modifies, adds, deletes. And with all those tools, you can just provide a Danger file, that is a configuration file, that will tell Danger to do some warning according to those. So you can check if the changelog file was modified. If it was not modified, you can warn. You can warn about the missing changelog and similar stuff like that. And because you can integrate Danger with your continuous integration, you can create a bot. So don't be afraid with the concept of creating a bot. It's just a simple matter of just creating a new user, a basic user in your GitHub account, and creating an access token for it, and that's it. You have a bot. And then you give the token to Danger, and Danger will be able to use the bot to comment on your pull request to provide the feedback. So you can comment on the pull request as a whole, or on specific files and specific lines. And it saves you a lot of time to avoid repeating yourself, and you can focus when you do your manual code reviews on interesting stuff. The next topic I want to talk about is tests, but in a manner that can be surprising, maybe. You might have heard about in talks about how to automate tests, how tests are important, and how to run, how to automate the running of the tests and the UI. That's something that is important to automate. But before you can automate your tests, you have to create the tests. And I know that everybody in this room loves to write tests, right? We all love tests. Right. So I know that it's something that if you're not used to, especially if you're not used to write tests or you never wrote tests, it's a high barrier to entry. because you feel that you don't know what to write as a good test, and you feel that you're going to have to write a lot of code, maybe more code in the test than in the implementation. It's going to be some boring code to write. So the first thing before automating the running of the tests is to actually automate the generation of those tests. So that's something that we just started experimenting at my company. It's brand new for us. Before we wrote tests manually, but we are experimenting with something called Cucumber and Gherkin. Some of you might have heard about those. So basically, what those frameworks does is Cucumber is the framework, testing framework, and Gherkin is the language, the syntax. And what those frameworks do is that they take a feature written in Gherkin and generate the test for you from that. So basically, you can ask your product owner to write your features using something like that. So that's what Gherkin looks like. Your product owner is able to, or even your QA team, maybe is able, or whoever writes the specs on your projects, might be able to write the user stories with this language. They're usually for if you are doing user stories and Scrum and stuff, you probably are already familiar with the vocabulary of feature, given, when, and then. At least the people who do the spec will probably be familiar with them. So if your QA team or if your product owner wants to write the tests, the test suites, then they can use Gherkin to write those. There are actually tools to help them write those, like HipTest is one of them. And when they have written all the specifications, they provide you those Gherkin files, or HipTest can provide them for you, and you integrate that in your project, and you use Cucumber to run those features. So what this means to run those features is actually, and to generate the test for those features, is it will just do any work that is needed to generate the test case that chain all those individual steps. You still have to implement the steps manually, so you'll still have to write some Swift code or Kotlin code to tell your project what does this mean to have n items in your cart. But it's only the atomic features that you're going to have to implement. So imagine that the vocabulary that's manipulated with the specification is just composed of 3 or 4 atomic features, like given I have 3 n items in my cart, you can just tell Cucumber what this means in terms of Swift code. Maybe it's probably going to be instantiating n product classes, an instance of your product classes, and then put that in the content property of your cart or whatever. So it's only like maybe 3 or 4 lines of Swift just for this atomic part. And even if you're, if the one that wrote the specification in Gherkin use that sentence in many cases, in many tests, you only have to implement that atomic step once. So that means that maybe you have, like, I don't know, 50 different steps that are used across your projects, but across your tests, and you only have to provide the implementation for those 50 steps. But then Cucumber will compose all those steps together to make the full test suite that your QA or product owner wrote. So I hope that with this solution, it will lower the barrier to entry of writing tests, less code to write, and easier to reason about, because it's just in terms of small stuff. But then, of course, once you have those tests, you will want to automate their execution. So I don't know if anybody doesn't know about Fastlane. If you don't, that's okay, but it's really famous now in the iOS community, so you might already use it. If you don't know, Fastlane is a tool to automate a lot of actions that you do in your everyday developer life, especially in terms of building your projects, running your tests, and uploading to the App Store and stuff like that. So what you do with Fastlane is you configure a fast file to tell you, OK, when I ask Fastlane to run the tests, what it actually means is that it runs the test in Xcode. Well, it runs that from the command line, but it does the same as if you did command U in Xcode to run your tests. And once it has done that, so that's the scan action. So the Fastlane comes with a lot of actions that are prepared for you, and you can just call scan, and it will do everything that is needed to execute the unit tests using Xcode build from the command line on your project. And once you have run that action, you can ask Fastlane to do other stuff. So in my example, I ask Fastlane to execute Slather, which is the second action here. What Slather does, it collects all the coverage data that Xcode might have generated once you've run your tests. And it converts all those data so that you can use that in Sonar, for example, or any dashboard tool that you can use. And then once you have all those outputs and reports, you can actually tell Fastlane to send all that to Sonar. And once you have done all that, well, you can send a nice message to Slack to tell, OK, the tests have passed, all is OK, or maybe your coverage was lower than before, or maybe the test has failed. So that's just an example of a lane. That's what's called a lane in Fastlane. Whenever I want to run the tests, I actually want to do more than just run the test, but do all that. You can do whatever you like in a lane. That's just an example. So another one would be to provide an over-the-air IPA or IPK in your QA team. So at my company, we use Fabric, but if you use anything similar to Fabric, but a competitor, there are also actions in Fastlane for many services. It's plugin based actually, so if an action doesn't exist, you can create one. So for the lane that we called OTA in my example, what I want to do is to execute those 4 actions, then stack. And what those actions do, so the match action will actually save you an aspirin. I'm talking about code signing here. So every problem that you have with code signing, Match will take care of downloading every profile and keys that you will need for your code signing of your project, so that you be sure not to have to reason about that manually. And when Match has run, I've just told Fastlane to run Gym, which is the action that they named for creating an archive and then exporting that archive into an IPA. And then it will run Fabric, which will actually take that archive and upload that into Fabric Beta. If you use any other service, you will just replace Fabric with the proper action there. And maybe in addition to sending that to Fabric Beta, you will want to send that to test flight. So the action is called pilot for that. It's all in the documentation, don't worry. But pilot will take your IPA binary and will send that to test flight and might even invite users for you. What is interesting with those solutions is that you don't have to wait for the previous step manually in front of your computer to run the next one. So even if it's directed to the store, you can just ask Fastlane to run the store script that will do all the steps there. And you can go to lunch or coffee break or whatever and do your sport activity and go back, and you will have everything done by Fastlane. So you don't have to wait for the archive step in front of your computer for the build and archive step to finish to then do the screenshot manually, and then to wait for those screenshots to be ready to upload that with application loader and whatever. Everything is provided by Fastlane and executes one after the other. If you don't know about Fastlane or are interested in more examples, I encourage you to go to a quickie that is later this afternoon, when you will have a demo about especially the screenshots and how you can automate the screenshots of your application and deliver that to the App Store. Even if you know about Fastlane, what you might not know is Fastlane is actually available for Android as well. So once again, that's a tool that you can use to mutualize stuff between iOS and Android. Typically, when you work on an Android project, you already have Gradle that does a lot of what Fastlane does, especially automating the builds. But Fastlane adds a lot of interesting features to that, actually the same features that it adds to iOS, mainly the screenshots and the upload to the App Store can be automated with Fastlane. Well, sorry, not the App Store, the Google Play Store. They can be automated with Fastlane as well. So you can automate the screenshot of your APK and the upload of the APK to the Play Store the same way that you can do for iOS. So if you just generate code but never do deliveries on the App Store, maybe you will stick with Gradle. To the Play Store, maybe you will stick with Gradle. But if you do, if you're responsible for uploading all your binaries to the store, even for Android, Fastlane can be useful for you. And of course, last but not least, I wouldn't have a talk about automation without talking about continuous integration. Basically, what continuous integration does, it orchestrates all the tools that we saw before. For example, it can detect when you do a code review using a pull request, and when you open the when you create the pull request on GitLab or GitHub or Bitbucket, it will execute the steps automatically on virtual machines. So there are multiple services for continuous integration. You can roll your own machines, your own Macs, maybe Mac Minis in your company, but you can also use other services that provides those virtual machines for you. So less maintenance for you to do on those machines. And then you can tell the continuous integration that whenever I do a pull request, let's just spawn a new virtual machine, clone my repository in it, install the pods or the provisioning profiles if you don't use Match, for example, and then run the actions. Like maybe if you use Fastlane, you will just run Fastlane store or Fastlane test to run those actions. Even Danger, so the tool that I talked about to automate the code review. This is where it's run, because every time you do a new commit on a pull request, it will retrigger the continuous integration, and Danger will scan the new code that you updated and do more comments. And once you have configured your continuous integration, whatever service you use, either to trigger on a pull request or on a commit, new commit, or on a tag or whatever, you can then use this to feedback to your project. So, as I said, with Danger, you can already use that to provide comments on your pull requests. But your CI will likely be able to also tell inside your pull requests if the CI was a success or a failure. So if you ask your CI to run your tests and the test fails, your GitLab or GitHub will tell you that it has failed to run the pull request, and it will forbid you to merge it until you fix the tests. And of course, you can use Fastlane to trigger messages in Slack, but you can also use your CI to tell you if anything went wrong during the steps of the CI. So maybe even when cloning the code, it failed to clone, You can tell your CI to put a message in your Slack. And there is always multiple tools. Like I said, I didn't provide any exhaustive lists of all those tools. So there's plenty of tools to automate stuff, but there is also multiple ways to do the same stuff. So here we can see that to send a message to Slack, we can either use Fastlane or directly Bitrise, but that's okay. You can just use the right fit for you. Whatever you use, it's always important to have automatic feedback anyway. And I think that's the whole process. So if you follow along on the top, you saw that we went from the creation of a project, so adding libraries and generate a database. So that means once we're here, we already have some stuff virtualized with Android. Even for development, the resources and the localization, we've virtualized stuff with Android as well, but we have also generated some code using SwiftGen, using Poesy, and using Sourcery. So a lot of stuff that allows you to reduce the number of errors. And all the quality and the checks and the reviews has been automated as well. And all the release to the test flight, to Fabric or to the App Store or the Play Store has been automated as well. So success, we've automated all the things. And as I said, some of those tools you might already have known, like probably Fastlane, CocoaPods and stuff, tools like those. Maybe some of you already know those, but I hope with this talk that you learned new tools, especially in terms of resources and project generation. And the conclusion would be that it's still important to automate stuff. It won't steal your work. You will still have some work to do to write code and to code review manually. But it's important to not do all the things over and over again, both because it's error-prone, but it's not fulfilling. You will not appreciate your work if you do repetitive tasks. So if you let the robots and the bots and the tools do all that work for you, you will have more time to discuss with your team, and your team will be able to focus to more interesting things, and will be more motivated as well. So that's all for me. Thanks you all. I hope you learned some stuff with that talk. And as I said, it was just a big picture, so you don't hesitate to ask me questions there, or even come to me later during the conference if you're interested in talking more about some specific automation or any tools. Thank you.